Hello everyone, new day, new LeetCode question, and let's see what it is today. Okay, today is medium with very low acceptance rate. Okay, check if a parenthesis string can be valid. It's a string containing only open and closing brackets. It is valid if any of the following condition is true. It is open and close bracket, can be written as AB. It can be two valid strings or it can be valid string inside of the valid string. You give parenthesis string s and a string locket. Both of length and locket is binary string consisting only of zeros and ones, and for each index I of locket. If locket is 1, you cannot change. If locket is 0, you can change to either open or close bracket. True if you can make as valid parenthesis string, otherwise return false. So we can probably use some kind of recursive solution. So we can take the string and check if it can be so we can check if some string is valid, parenthesis string. If it is not, we can change first we will get square explosion of variants with changed and unchanged. Changed and unchanged brackets. The way to check if string is valid parenthesis string is to put it to the stack and push new parentheses and pop all parentheses. How we can work with this approach? Let's see, maybe there is a hint. Yes, there is a hint. Let's check what is the hint. Can odd length string ever be valid? So, okay, we can check if it is odd. It's like it's obvious, yes. From left to right, if a locket is uncountered, it must be balanced with either a locket or unlocked index on its left. If neither exists, what conclusion can be drawn? If both exist, which one is more preferable to use? From left to right, if a locket is encountered, it must be balanced with either a locket bracket, open bracket, or unlocked index on its left. Okay, let's see third hint. I have no idea how to solve this question. I will revisit it later. And right now we will take solution from the top 150 list. And not daily question, but top 150, and we have majority element question, and it is easy majority element. So for example, we can so basically we have to count the elements in the array, but there is a catch that our element is more than half of the array. I remember that question. I heard about this question, or I don't know. We can find the majority of elements if we will assume that first element is majority. Yeah, there is follow-up like that. So we are assuming that this element is majority, and we taking this element, saving it as int current element equals nums 0. We have int count equals 1, and for each element we will increase the count if it is the same element. If it's not the same element, we will decrease the count. And if count after decrease count is 0, we will swap element, or count is negative. Yeah, if count is negative, we will swap element, probably. So for int I in nums, we will try the following. If cur equals I equals not equals equals I count plus plus, else count minus minus. If count is less than 0, current equals if count if count equals 0, current will be I, count will be 1, else So if decremented count if less than 0, we will set a new element as current and count will be set to 1, or maybe like that. So if we met some element, some different digit twice, different from original digit twice, we can assume that at least on this part of the string of the array, our first assumption was wrong and it is not majority. And on the next part, we will start from fresh, from the beginning, basically. And at the end, we will have let's check on this. No, it should be less than 0. So we are going here. It's 3 and count 1. We are subtracting 1 count from 3, but 3 still current element, and here we have the our majority return current. And here we're taking 2 and 1, 2 and 2, 2 and 1, 2 and 0, 2 and -1, and 1 became new current, and the count is 1, count is 0, count is -1, and 2 became current, and we return count. Let's check correctness. Yes, and let's check performance. Wrong answer. Okay. Expected 5. Output is y. So we're taking 6. Yeah. So there is a problem. Int I equals 1, I less than length and I plus and nums I nums I. Let's check again. Use this case to check. Okay. Yes. Okay, and submit. Good. So we are good here. And memory wise, we're also no, memory wise we are a little bit below, but yeah, okay, I'm satisfied with this. We done it in linear time and linear O1 memory. So description, yes, we done it in O1 space because we only keep current and count. Okay, see you tomorrow.